In this video, I'll discuss the effective nuclear charge. So, ano yung effective nuclear charge? So, meron tayong atom, meron siyang nucleus, tsaka may mga electrons siya na nagre-revolve around the nucleus. So, kung walang obstacle or kung walang something in between nung inyong electron tsaka nucleus, the electron experiences the full magnitude of the nuclear charge Z. Okay, so ano yung force na yun? That is the force of attraction. So, F, yung electrostatic force is equal to K times yung Q ng inyong nucleus times yung Q ng inyong electron, so these are the charges of the nucleus and the electron respectively, over the square of their distance, which is R. Okay? So yun yung distance nila. So yung Z, yun yung na-experience ng inyong electron na charge ng nucleus. Okay? So walang obstacle in between the nucleus and the electron, so na-experience niya yung buong Z niya. So yung Q sub N nyo, that's Z. Okay? So kapag ka naman electrons, okay, maraming electrons sa inyong atom, meron kang outer electron and meron kang inner electrons. Okay? So yung outer electron, they only experience a large fraction of the nuclear charge, not the full magnitude. Pero large fraction pa din, generally. The inner electron shields the outer electron from some of the nuclear charge. So hindi niya na na-experience yung full magnitude ng ating Z. Ang na-experience na lang niya ay yung tinatawag nating effective nuclear charge. So the effective nuclear charge is equal to the Z or the charge of the nucleus, or yung tinatawag nating nuclear charge, yung walang effective kasi that's the full magnitude, minus the shielding constant. So yung shielding constant nakadepende yan sa manner of shielding ng mga inner electrons. Okay? So ano nga ba yung shielding? Shielding is the partial blocking of the outer electron by the inner electrons. So kapag ka outer electron ka, yung mga inner electrons, sinishield niya yung ibang magnitude ng inyong nuclear charge. So ang na-experience lang ng inyong outer electron is the Z effective imbes na yung ating full nuclear charge Z. Okay? So some notes on shielding. So number 1, electrons at higher N are shielded by the electrons of lower N. Okay? So the shielding is also cumulative. Ibig sabihin, nagpapatong yung mga shielding ng ating mga electrons as you go from lower N to higher N. So ano ibig sabihin nun? So if you have the innermost electron here na experience yung full nuclear charge Z, which is the largest magnitude, okay? So kapag ka meron ka namang electron above that inner electron, yung N equals 2, so ang na-experience niya ay Z effective 1. So that's less than the full magnitude of your nuclear charge. Kasi nasi-shield siya no N equals 1 electron. Yung electron na nandito sa N equals 1. Okay? So kapag nandito ka naman sa N equals 3, ang na-experience mo naman ay ibang Z effective. That's the Z effective 2. So that's less than the Z effective 1, which is also less than the Z effect or the Z which is the full nuclear charge. Okay? Kasi nasi-shield naman siya both by N equals 1 and N equals 2 electrons. Okay? So nagpapatong yung shielding, cumulative siya. Okay? So effective ang shielding in between N. So yung lower N, nasi-shield niya yung mga higher N na electrons. Okay, yan yung pinaka-effective na shielding. Shielding between N. Okay? So for number 2, for electrons of the same N, electrons of higher L are shielded by electrons of lower L. So, sinasabi naman niya dito na electrons within the same N, or ibig sabihin, same N sila pero magkakaiba sila ng subshell. Magkakaiba sila ng L. Okay? So, for example, meron tayong N equals 1. So, isa lang naman ang subshell niyan, yung 1s. Okay? Pero sa N equals 2, meron tayong tinatawag na 2s tsaka 2p. Okay? So, dun sa N equals 2, meron tayong dalawang subshells. Yung 2s and 2p. So, ang sinasabi ng number 2, okay, nasi-shield ng 2s and 1s yung 2p. Okay? So, nasi-shield ng 2s yung 2p kasi yung 2p mas mataas ang kanyang L. Okay? Hindi nasi-shield ng 2p yung 2s. Ang nag-shield lang sa 2s ay yung 1s electron. Okay? So, ganun pa rin yung relationship ng mga Z effective. The full magnitude is of course the greatest. Tapos yung Z effective caused by the shielding of the 1s, yun yung na-experience ng ating 2s. That's the next one or the next value, yung less than Z. Tapos finally we have the Z effective 2, which is the least in terms of the magnitude. Okay? Kasi nasi-shield siya both ng 1s and 2s electron. Okay? So for number 3, electrons at lower L values shield more effectively. Kasi kung titingnan nyo yung mga orbitals or yung mga subshell shapes, okay? Yung mga shapes depende sa L, makikita nyo na yung S, pinaka-condensed yung kanyang wave function. Okay? It's spherical. So, mas effective siya mag-shield. Pag pumunta kayo sa P, mas dispersed na yung orbital. Lalo na pag pumunta kayo sa D at F. Kasi nag-i-increase yung dispersion ng ating mga wave function kapag tumataas yung L. So, nagiging poorer shielders sila. Okay? So, yung F, tsaka yung D, tsaka yung P, they are poorer shielders. So, mas effective na shielder yung S. So, mas effective mag-shield ang P kaysa sa D, and the D is a more effective shielder than F. Pero yung dalawang to actually ay poor shielders na. Makikita natin ito sa mga effects niya sa periodic table of elements. Okay? So, finally, number 4, electrons at the same subshell also shield each other, though only weakly. So, kung meron kang electron na nasa iisang orbital, okay, kung dalawa sila, I mean, yung dalawang electrons na yun, nag-shield sila ng isa't isa. Pero that's the weakest type of shielding. Shielding of electrons in the same orbital. Okay? So what are the consequences of shielding? So kapag in-apply na natin to sa periodic table, the effective nuclear charge across a period increases from left to right, while the Z effective decreases down the group. Kasi from left to right, hindi masyadong nag-change yung ating N. Okay? So if you look at the periods, diba, same lang yung N nila. 1, 2, 3, 4, 5, 6, and 7. So ang nag-change lang dito yung L. So S, D, and this is the P block. Okay? So ang nag-change lang yung kanilang subshell. So hindi nag-change yung kanilang principal quantum number, o hindi nagbabago yung distance nila masyado from the center of your atom. So ang nangyayari, if we write the equation again, Z minus sigma is equal to the Z effective. Okay? Hindi nako-compensate ng increase ng shielding constant yung increase ng nuclear charge. So palaki ng palaki yung nuclear charge, pero yung shielding nyo hindi ganun na nag-i-increase because the shielding is not as effective. So overall, nag-i-increase yung Z effective from left to right across a period. Pero kapag down the group naman, nagde-decrease yung Z effective kasi nag-i-increase yung N nyo. Okay? So if you go from hydrogen to lithium to sodium, magkakaibang N na yun. So, ibig sabihin, malalayo na yung mga distances ng mga outer electrons compared to the change kapag from left to right lang. So, mas effective or mas mataas yung change sa shielding constant at nako-compensate niya yung change sa ating nuclear charge. So, therefore, the overall effect is the decrease in the Z effective. Okay? So, what are the effects of your increasing Z effective? So, ano nangyayari pag nag-i-increase ang ating effective nuclear charge? So, number 1, electrostatic force of attraction between the nucleus and electrons increases. This is obvious kasi tumataas yung Z effective. So, therefore, tumataas yung electrostatic force. Okay? Again, isusulat ko yung equation. K, Q ng nucleus, Q ng electron over the R squared. So, yung Q ng electron, that's the Z effective. Okay, that's the charge or the nuclear charge. Okay? So there is a greater pull from the nucleus kasi mataas yung ating electrostatic force. So anong nangyayari kapag gano'n? Kung greater ang pull, ibig sabihin, lumiliit yung ating atom. So increase in the Z effective decreases the atomic size. Okay? So some consequences. Transition metals have relatively smaller sizes due to the poor shielding. So shielding between electrons in the same orbital is the poorest type of shielding. So, siya yung weakest type of shielding. So, pansin nyo, 10 yung kailangan yung electrons para mapuno yung d orbital. Okay? So, ibig sabihin yung Z, okay, pataas lang siya ng pataas kasi that's from scandium, for example, to zinc. Meron kang additional na 9 protons. Pero yung 9 electrons na dinagdag mo, hindi niya na-shield yung isa't isa effectively. So, ibig sabihin, paliit ng paliit yung iyong atom. Okay? So, therefore, pagdating mo sa zinc, sa cadmium, sa mercury, tsaka sa copernicium, maliliit na silang atoms compared sa mga atoms na nandito. Kasi yung Z effective natin ay drastic yung change. Okay? So, ganun din ang nangyayari sa mga F-block elements. Actually, mas drastic pagdating sa F-block kasi 14 electrons before you fill the whole subshell. Okay? So, ang nangyayari, yung lutetium tsaka lawrencium, sobrang liit na nila compared sa lanthanum and actinium. Actually, may tawag dito sa mga drastic changes na to. Ang tawag dito ay transition metal contraction, and this is the lanthanide or actinide contraction. So that's the phenomenon caused by the drastic decrease in size due to the increase in the Z effective. Okay? So another consequence of increasing the effective nuclear charge is that electrons become more difficult to remove from the nucleus. So kung pagsasabihin natin ito in other terms, nag-i-increase yung kanilang tinatawag na ionization energy. So ionization energy is the energy needed to remove the outermost electron of an atom. Okay? So kapag in-applyan mo siya ng ionization energy, itong atom na to, for example, magkakaroon ka ng free electron, yan yung na-eject na electron, plus yung inyong ionized atom or yung inyong ion. So by the way, cations are positively charged ions and anions are negatively charged ions. Okay? So some consequences, alkali metals are more commonly existing in their +1 state. Okay? So for example, we have sodium and potassium. So yung sodium and potassium, they are both in the group 1 of your periodic table. So they exist as sodium plus and K plus respectively. So mahirapan ka makakita ng Na and K sa environment na neutral ang state. Usually sila ay naka +1 state kasi mas stable sila sa ganyang state. Okay? So another one, alkaline earth metals or alkaline earth metals more commonly exist in the +2 state. So ito naman yung mga nasa group 2. Okay? So for example, we have calcium and magnesium. They usually exist in the form calcium 2 plus and magnesium 2 plus respectively. Okay? So mahihirapan ka maghanap ng calcium and magnesium na neutral except for some cases wherein part sila ng isang mineral or substance. Okay? So for C, transition metals usually exist as cations. Kasi mga transition metals, they have a low ionization energies. So madali silang ma-ionize. Okay? So examples, we have chromium 3+, manganese 2+, and the scandium 3+. Okay? So also, increasing the effective nuclear charge increases the tendency of the atom to capture electrons. So, in other words, nag-i-increase naman yung kanilang tinatawag na electron affinity. So, what is electron affinity? Electron affinity is the energy released naman kapag ka nag-combine yung inyong electron or pumunta yung iyong electron dun sa atom. Kapag naging part na siya ng mga orbitals or ng iyong electronic structure ng inyong atom. So, nagre-release siya ng energy in the form of your electron affinity. So, yun yung tawag doon. That's the energy released when your atom captures an additional electron. Okay? So, more consequences for this. Letter A, halogens more commonly exist in their -1 state kasi matataas na yung kanilang ionization energy. Kaya na nilang mag-capture ng electron. So, yung fluorine and fluorine, for example, they exist as fluoride and fluoride respectively. So, kapag ka naman chalcogens, okay, sila yung mga nasa group 16, katabi ng halogens. So, they usually exist in the -2 state. So, for example, meron kang oxygen and sulfur. They usually exist in the oxide and the sulfide states, yung mga O2- saka S2- respectively. So, may mapapansin din tayo dito. Note that the more common states are isoelectronic to noble gases. So, balik tayo dito. Okay? So, for sodium and potassium, yung sodium plus and potassium plus, meron silang isoelectronic atom. So, yung sa sodium plus, kapareho niya ng number of electron yung neon. So, sodium plus and neon have the same number of electrons. Kasi yung neon, meron siyang tinatawag na noble gas configuration. So, that's a stable configuration. Okay? So, fina-follow siya ng sodium plus, and yung potassium plus, fina-follow naman niya yung argon. Okay? So, they usually tend to become atoms with the noble gas configuration. Kasi mas stable yung configuration nila. Okay? And since mababa yung kanilang ionization energy, they tend to just release 1 electron kaysa mag-capture sila ng 7 more electrons para lang sa octet rule. Okay? Mas gusto nila na tanggalin na lang yung extra electron para magkaroon sila ng noble gas configuration. So, ganun din yung case sa halogens and chalcogens. Okay? So, yung F-, isoelectronic siya sa neon, pareho sila ng number of electrons. Yung iyong chloride, okay, isoelectronic naman siya sa argon. Okay? Yung oxygen and sulfur, isoelectronic sila sa neon and argon respectively. However, this is not the case for transition metals. Kasi one property of transition metals is that they can have multiple states. So for example, yung chromium 3+, meron din tayong chromium 6+. So for Mn, meron din tayong Mn7+, aside from the Mn2+. Okay? So they are not necessarily following this noble gas configuration or the octet rule. Okay? So for the next one, atoms with high effective nuclear charge values have electron clouds that are more difficult to polarize. Okay? So what is polarization? So polarization is the redistribution of an electron density due to its reaction towards an external charge. So, kung meron tayong unpolarized atom, tapos lapit tayo ng isang external positive charge, for example, na-attract yung electron density towards the charge. So, namomodify natin yung structure ng electron cloud. Okay? So, anong nangyayari? Napopolarize siya. Napupunta sa isang side yung negative charge density, tapos napupunta sa kabila yung positive charge density ng atom kasi na-polarize na siya due to this external charge. Okay? Mas madaling gawin yon kapag mababa lang yung interaction between the nucleus and the electrons ng atom mo. Kasi hindi ganun kalakas yung force of attraction. So, madali lang masway yung electrons kapag meron kang external charge. Pero kapag mataas yung effective nuclear charge, mas matigas yung electron density. So, mahihirapan kang i-polarize yung mga ganung atoms. Okay? So, therefore, increase in the effective nuclear charge decreases the polarizability. Mas mahirap i-polarize ang mga atoms na may mataas na effective nuclear charge. Okay? So, given the set of elements, paano natin sila i-arrange based on their periodic properties? Okay? So, tandaan natin na kapag higher ang N, mas mababa ang inyong effective nuclear charge. So, kapag mas mababa ang effective nuclear charge, mas malaki ang size kasi yung interaction ay mas mababa. Okay? Yung interaction between the nucleus and your outer electron, mas mababa yun. So, madali rin siyang i-polarize. Okay? So, the polarizability is increased. Madali ring i-ionize ang iyong electron. So, mas mababa yung energy required. So, therefore, mababa yung ionization energy. And then, mawawala na siya ng tendency to capture additional electrons kasi mababa na nga ang kanyang effective nuclear charge. So, higher N also means higher metallic property. So, kapag mataas ang metallic property, ibig sabihin, actually, ito ay collection ng mga properties like size, polarizability, and ionization energy. So, mababa ang ionization energy kasi metals usually exist as cations. So, mataas din ang kanilang polarizability and malalaki ang kanilang size. Okay? So, for example, arrange the following elements in order of increasing size. So, we have potassium, magnesium, molybdenum, chromium, silicon, and carbon. So, ang una nyo gagawin is segregate nyo yung mga elements with their or based on their N or principal quantum number. So, makukuha nyo to based sa periodic table or sa kanilang electron configuration. So, for carbon, we have N equals 2 kasi siya ay nasa 2p subshell. Yung silicon and chromium nasa N equals 3 kasi yung silicon ay nasa 3p orbital. Yung chromium ay nasa 3d. Yung potassium and molybdenum naman ay parehong nasa N equals 4. So, yung potassium nyo ay nasa 4s, yung inyong molybdenum ay nasa 4d. Okay? So, pagkatapos niyan, compare the blocks. So, S block elements are bigger than F block elements, than D block, than P block kapag nasa parehong N. So, syempre, pinakamaliit si carbon. So, nandyan siya. Then, followed by silicon. Kasi, silicon is in the P block. Tapos, yung chromium nyo ay nasa D block. So, mas malaki si chromium kaysa kay silicon. So, next is between potassium and molybdenum. Syempre, si molybdenum ay nasa D block, si potassium ay nasa S block. So, mas malaki si potassium kaysa kay molybdenum. So, this is the final arrangement for the set of elements in order of increasing size. Okay? So, for other properties, syempre, kapag increasing polarizability and size, pareho lang yung trend. So, kung ano yung arrangement na to, pareho lang siya kapag sa polarizability. So, pagdating sa ionization energy and electron affinity, baliktad naman yung trend. So, kapag kasi binaliktad mo yung arrangement, ibig sabihin, increasing naman ang kanilang effective nuclear charge. So, nag-i-increase din yung ionization energy and electron affinity. So, kung ano yung trend sa polarizability and size, kabaliktaran nun yung trend sa ionization energy and electron affinity. Okay? So, now let's discuss isoelectronic atoms. So, again, isoelectronic atoms are atoms with different Z, magkaiba sila ng atomic number, pero magkapareho sila ng number of electrons. Okay? So, in this example, arrange the following in order of increasing size. So, we have the oxide, O2 minus, we have the fluoride, neon, sodium plus, and magnesium 2 plus. So, pare-pareho lang sila ng electron configuration. Okay? Helium, 2s2, 2p6. Pare-pareho sila ng number of electrons. Ang pinagkaiba ng nila ay yung kanilang nuclear charge or yung kanilang atomic number. So, kapag i-arrange mo sila in order of increasing size, syempre kapag bumababa yung Z, since constant ang inyong shielding constant, so sulat ko ulit yung formula, Z minus sigma is equal to Z effective. Okay? Constant ang ating sigma or yung shielding constant kasi pare-pareho sila ng number of electrons. Ang nagkaiba lang ay yung kanilang Z. So, kapag nag-i-increase yung Z, nag-i-increase yung Z effective. However, kailangan natin silang i-arrange in order of increasing size. So, dapat mas mababa yung Z effective nung pinakamalaki. So, dapat i-arrange natin sila in order of decreasing Z effective. So, dapat i-arrange natin sila in order of decreasing Z. Okay? So, kapag in-arrange mo sila in order of decreasing Z, pababa rin yung Z effective, therefore, pataas yung kanilang size. So in order of decreasing atomic number, we have this arrangement. So magnesium 2 plus muna, followed by sodium plus, followed by neon, followed by F minus, and then we have the oxide. Okay? So ito yung discussion ko on the periodic trends. Sa susunod, ang didiscuss ko naman ay yung chemical bonding. So we'll introduce you to chemical bonding theories and different Lewis structures. Okay? So see you next video.